The next step is to use Edge Impulse to design and train an image classification model. Begin by logging into Edge Impulse and creating a new project. Name the project Tire Classifier and click Create New Project. Hit OK after the project is successfully created. This takes you to the project dashboard where it shows different details about the project and where you are within the project workflow. The first step is to upload the image dataset we just created into this project. This can be done directly from OpenMV IDE. Click the Tools menu, then Dataset Editor, then Export, and then log into Edge Impulse account and upload to project. When prompted, enter your Edge Impulse username and password and hit OK. The next prompt will ask you to select a project from your Edge Impulse account. Select the Tire Classifier project that was just created and click OK. The next prompt asks what % of the data should be split between training and testing sets. Leave this at the 80-20% split that's default and hit OK. An upload progress bar will show as the dataset is being uploaded to the project. When it's complete, you'll see a pop-up with the upload statistics, which shows that all 900 images from the dataset were successfully uploaded. Back in Edge Impulse, click on Data Acquisition to see the images that were uploaded to the project. On this page, you can see a list of the images that were uploaded as part of the training data split. Click any image name to see a preview of it. You can see the class label also exists for every image on the list. Click on the Test Data button to see which images were split into the test data set. Explore these images by clicking them to see a preview. Next, click on Impulse Design to begin creating a new impulse. An impulse is a chain of processing blocks that are arranged and configured to accomplish a machine learning task. There is a default block for image data. This block will resize our input images into 96 by 96 pixel images, which work with the default model we will use. Leave this block as is. Click Add Processing Block. In the pop-up menu, click Add on the image item. This adds a new image block that defines our input into the learning block. Click Add Learning Block. In the pop-up menu, click Add on the Transfer Learning item. This adds a new Transfer Learning block that will be used to build and train an image classification model. Click Save Impulse. Next, click on Image. This page is used to set the parameters and generate features as part of the image block of the impulse. Images are converted into lists of features before being input into the machine learning model. Because our dataset images were captured in grayscale, change the color depth option to grayscale. Then click Save Parameters. On the Feature Generation page, click Generate Features. Processing logs will be displayed in the output window. When processing is complete, the Feature Explorer will show a 3D chart which represents each test image as a data point. The chart is color-coded by image class. The clustering and separation of the data points can give insight into how well the classes will be distinguished by the model. Next, click on Transfer Learning. This page gives options for changing the training settings and the neural network architectures. The training settings control how many times the model is exposed to the training data and the size of adjustments made to the model's weights after each learning step. Leave the training settings at their default values. The network architecture options control the structure, size, and type of network that the model uses. The input layer is made up of the features that were generated for each image, and the output layer has 3 features representing the 3 image classes we are training for. Click Choose a different model. Then click Add for MobileNet V2 96 by 96 0.35. This selects a pre-trained MobileNet model that will be used for transfer learning. The model has already been trained on a lot of images and this process will train it further for our specific image classification task. Click Start Training. Processing logs will be displayed in the training output window. When processing is complete, their overall model accuracy is shown. A confusion matrix is included which shows which image classes were labeled correctly and what they were mislabeled as. A 3D feature explorer chart is also shown, which is color-coded by class and correctness. This model was able to achieve an accuracy of 98% against the validation set, which is very good for performance for our application. Next, click on Model Testing. This will allow us to further test the accuracy of our model by applying it to the test split of our data. Click on Classify All. Each test image is run through the model and its resulting classification is compared against its known label. After the processing is complete, an overall accuracy is shown, as well as a confusion matrix and a feature explorer. This model reached an accuracy of 99% against the test data.